we're moving on to the next lesson today. We're sticking with, and I actually used to do this. I taught it in a different order. So there's kind of like two halves of today, and I used to flip-flop them. But I'm going to start with this one for two reasons. I honestly think this is the harder part of the lesson, but also this is a little bit more directly related to the exponential stuff we were doing with the last lesson. If you were here on Wednesday, we did test corrections. If you want to see your test and see what you got to see if you need to do test corrections, let me know. I can get that to you. The biggest thing is I broke it down for you. I try to break it into these steps. And so we are solving these exponential problems. And again, an exponential is a problem that has the variable as an exponent. First step is get that base to be the same. So you want both sides to have the same base. Now, if you look at these first like 5, 6, 7 problems we do, they already are the same. So they have 2 4s, 2 5s, 2 10s. So that first step is already done. I wanted to get some practice with that part before we get into that. Because honestly, that's really, in my opinion, that's the hardest part. Once you get the bases to be the same, step 2 is you're going to set your exponents equal to each other. And step 3 is you're going to solve. That solving step should be the easy part. Because you guys should be pretty good at solving linear problems by now. You guys should have been pretty good at it in Algebra 1, but then here in Algebra 2, we've been doing it just about every chapter this year, so you definitely should be getting pretty good at that last part. So I'm going to get started, and this is a good way to kind of look at this where it starts from the very beginning, because I think if I would give you guys number 3 on the test right now, I think a lot of you guys would be confused. You wouldn't know what to do. On the other hand, now, if I put 1 on a test, I think a lot of you guys would probably be able to think about it and figure out what the answer is. Maybe not everybody, which is fine. I'm going to teach you how. But a lot of you guys maybe would. Because if you think about this logically, if 4 raised to the x is equal to 4 raised to the 5th, what does that x have to be? Got to be 5, right? 4 to the 10th can't be 4 to the 5th. 4 to the 13th, 4 to the 3rd can't be 4 to the 5th. The x has to be 5 because 4 to the 5th has to equal 4 to the 5th. Don't make that part harder than it has to be. Now, again, obviously it does get harder than that, but just that part, if I have 4 to the x is equal to 4 to the 5th, hopefully it makes sense that x has to be 5. Does that make sense? Explain that a little bit better. Okay. Now the next one we have 5 raised to the 2x is equal to 5 to the 6. Well, again, kind of the same concept over here. The x and the 5 are the same. Well, then this 5 to the 6 has to be the same as 5 to the 6 over here. So this 2x has to be the same as 6. So the x is 3. Now let's take a step back. How do we find that that x was 3? Well, if this was 5 to the 6, this one has to be 5 to the 6. So this 2x has to be equal to the 6. If you are still not understanding, just remember this step 2. Once the bases are the same, all you need to do is set those exponents equal to each other. So kind of the way I explained with number 1 and 2 is I kind of explained why you can do that. But really, all you need to know is that you have to do that. You don't need to know why. I guess you kind of need to know how to do it. You don't need to know why we're doing it necessarily. You just need to make sure you know if the bases are the same, we can set the exponents equal. So for number 3, 10. So we have 3x plus 4 has to equal 25. And again, if you want to know why we can do that, again, if you look back at number 1, more complicated equations, but it's the same concept. Earlier, once you get here, this better be the easy part for you guys. And if it's not, we need to figure that out. Because like I said, I try not to say things are easy in this class. I really try not to, because I know everyone has their strengths and weaknesses. But we've been solving 1, 2, 3-step equations. Again, you've been doing that since the beginning of Algebra 1. If you're not good at that by now, it's making me nervous. Subtract both sides by 4. That ends up being 7. Also, just to go back to that to make sure I reiterate, I'm not saying that you every time. I make mistakes when I solve problems all the time. You guys see me do it. But there's a difference between making a small mistake because you're going too quickly and looking at that problem and saying you don't know how to do anything. If you accidentally added 4 both sides, yeah, it's a mistake. I get it. Mistakes happen. Problem, you're like, I know what the next step is. That's an issue. So I guess that's a good way to say it. It's not easy in the fact that you guys should always get it right, but you should always know what to do. And last, number 4, again, this one's a lot more complicated, or I guess I should say it's just one extra step because now we have a variable on both sides. Technically, you guys maybe remember me saying this back in chapter 1, but technically there's 4 different things you can do right now and still get the right answer. I personally like to combine my variables first. Again, if you were doing it a different way, that's fine. There's a bunch of different ways to do that. That's just my personal preference. So that's 2x is equal to negative 18. 18. And if you divide both sides by 2, you get x is equal to negative 9. I'm hoping it's not too bad, but I want to get you guys good at this step and good at these that concept of setting those exponents equal to each other before I get into the part that's a little bit more difficult. Are there any questions before I let you guys do those next 3 on your own? All right, go ahead and do those on your own. I know you can't really see the problem for number 5, but those are all my answers up there. Don't make that part harder than it has to be. The bases are already the same, so all you do is set the exponents equal to each other, and then you're solving a linear equation. Any questions on those before we move on? All right. The next step is one where it gets a little bit more difficult. And just like any other problems we do, or most problems we do, some of them are a little bit harder than others, so we'll get to that. But these are all the ones where you have to do that step 1. You have to get the bases to be. What I'm giving is we have 3 raised to the x is equal to 9. We have 3 and we have a 9. So those 2 bases are not the same, so we cannot set the exponents equal to each other. Can't do that yet. We need to get the bases to be the same. Happen every single time. And we'll talk about that in a second and when it doesn't happen. But most of the time, you guys will have, if you're trying to get these bases to be the same, you're trying to get the bigger ones reduced down to the same base as the smaller one. So take 9 and make it 3 raised to some exponent. Sure, you can always use your exponent sheet. If you need exponent sheets, I've got plenty of them over here. You're more than welcome to take those. I will give those to you on the test, just like the last time. But on the exponent sheet, you can go through, we'll start with my 3's right here. So these are 3 squared, 3 to the 3rd, 3 to the 4th. Is 9 up here? Yeah, 9 is right here. 9 is the same thing as 3 squared. 9, we can replace that with 3 squared. And that makes sense because 9 and 3 squared are the exact same number. They look a little bit different, but they're the same. The analogy I used with my art class is if you had a dog weighing 90 pounds, technically you could say that he weighs 3 squared pounds. People kind of look at me funny, but 3 squared is 9. You'd be able to do that. So all I did was I took 9 out, but the thing I put back in was something that was 9, something equal to 9. And again, the reason I did that is because now they both have the same base. We will have some problems where we have to change those. We'll talk about that in a second. But for the smaller base is, that's usually what you're going to make it. So this one was 9. We changed it so the base is 3. 3 squared. The only other part. Everything else is the same. That's an easy part. A lot of students don't do well with that. Once we have the 3 squared, now the bases are the same, so we can set those equal to each other, and we can solve just like normal. But that first part, getting those bases to be the same, that's the hard part. Because students are reducing those down. I don't know if students don't like this concept because it's new. They don't understand it. But for whatever reason, a lot of students don't do well with this. One thing I will say is one thing that actually, I'm going to do a couple problems, then we'll talk about that. I don't want to say too much and confuse you before we get to some of these. So if I go to number 8, we have 4 raised to the, I think that's a capital X. I usually don't do that. Must have been an accident. Now again, the bases are not the same, so we have to change those. This base is a 4, the smaller base. So normally, usually, we're able to take that 16, we're going to make it the same base. Usually, not all the time. The quiz, that's how it's going to be. So is there a way that I can make 16? It's 4. If you don't know, go to your exponent sheet, where 4 is, and see if you can find 16 in that row. We'll use that here in a little bit, and it'll be a little more helpful. So the 16 goes 4 squared. The part doesn't change. 4 raised to the 4x minus 10. So you can set the exponents equal to each other. That was the hard part. Now, hopefully, it's not too bad. 10 to both sides. X is equal to 12. Both sides by 4. X is equal to 3. You can sub that in and solve. 4 times 3 is 12. 12 minus 10 is 2. So you can plug your answer in fairly easily for this one and check your work. Bad because most of you guys know 16. Most of you guys are able to come up with that. But what about number 9 where we have 2 and 64? Most of the time, I can break the bigger number down to make it the smaller number. So I want to see is if I take 2 raised to some number, would that give me 64? Well, then if you're not sure, especially this one is a big one, go on your exponent sheet, find where 2 is, and see in this column right here, keep in mind this column does keep going forever and ever. Look at that column. Is there a 64 on it? Yeah, 64 right here. So 2 to the 6th power is 64. You can't see it from your seat, that's x to the 6th. So 2 to the 6th power is 64, which means back on our notes, 64 to the 6th power. Don't forget, to the 6th, we still have an x. That 64 had an x. So I changed the 64 to the 6th, but we're still raising them to the x. Or did change. About that in a second. Left side we have 2x plus 24. Now we talked about this property when we did radicals for the last test. If you ever have an exponent raised to another exponent, you can multiply those. You to still not skip that step. The other class I told them they could skip it. I'm not going to make you. Skip that for the example we're going to do. I think the next one or the one after, I'll show you that. So I would not skip that step. But 6 times x is just 6x. Over here, we didn't change anything. So now the bases are the same. Now we can go ahead and solve that. 2x plus 24 is equal to 6x. Subtract 2x from both sides. We have 24 is equal to 4x. Divide both sides by 4, I get x is equal to 6. And then you can solve, you can simplify, check your work. Now the next one is where it gets a little bit more difficult. Now I will tell you, I'll go over this one, because I almost took this one off. You're completely lost. Yes, maybe it will be one on the test like that. Against the wall on this. I've had too many times, and this is one of the things I've learned across my years of teaching, where I will go over these and I'll have a student who understands how to do these, and they're okay with those, they're getting it, they're understanding it a little bit. But then they makes them then confused with these other ones, and so when they take the test, they actually do really poorly, and it's all because of this one that was hard. So, honestly, if you want to get like an A or B in this, definitely, you guys are all smart enough to do number 10. I very much have faith in that. But there's only going to be one, maybe two on the test like this. If there is two, one of them is probably going to be multiple choice. So I don't think 10 is much. I don't think it's much more difficult, but I just know from experience that a lot of students think it's difficult. Different with this one, it cannot break down into. So if you go over here with 9, there's no 27 on here. So I can't make 27 into 9 raised to some exponent. This is the one occurrence that happen very often, at least not in this class, that you're going to have to change both bases. So if you're going to change both bases, what are we going to change them to? What number would be good? Well, one thing to remember is the numbers have to, when you're breaking them down, they have to be smaller. And that's one thing I'll talk about in a second. But I also will tell you, if I give you a harder one like this, I'm going to try to make the part where you break it down, at least one of them I'm going to try to make pretty easy. So for instance, 9, I'm hoping you guys, the first thing you think is, well, 9 I can make 3 squared. Now again, I could give you a really hard number that's like 64, where it could be 8 squared or 2 to the 6 or 3 to, I could do one of those, I'm not going to. So if you look at this, the easy one or the obvious one I'm hoping is 9 is 3 squared. So let's try that one. And that's honestly the only thing 9 could be, so it better work. It's 3 squared. There's the x plus 2. Can I make the 27 into 3 raised to something? Well, now, yeah, 3 raised to the 3rd is 27. Now that does work out. So now we should be good. 27 is 3 raised to the 3rd. Now, again, I personally don't think that's much harder than the other ones, but I know a lot of people do. So, again, I very much think you guys are fine with that. I think you guys are all intelligent enough to do that. But again, the last thing I want you guys to do is lose sleep and then forget how to do all the other problems because you are trying to do this one so much. One thing before we move on, I will say, remember here I said I want you to show this step where you actually put it, you don't just multiply that in your head and skip down to this one. The reason is because of this problem. So they just skip and they say this is 3 raised to 2x plus 2. And distribute that. It's 2 multiplied by the whole exponent, so you have to distribute that. So that is another very common mistake with this one. So this is actually 3 raised to the 2x plus 4 is equal to 3 raised to the 3x. And now you can go ahead and set those equal to each other. Now we finally got to where we have 2x plus 4 is equal to 3x. If I subtract 2x from both sides, I get 4 is equal to x, and that is your answer. Now, again, I assure you, if I give you one like that, I'll try to keep it like that where they're not huge numbers. It's not going to be like, oh, this is 5 to the 13th and then 5 to the 5th or something. I'll try to do reasonable ones like that one 9 is 3 squared. I read like 36, that's probably going to be 6 squared. I know there's some, I don't know, 36 is other options. Any questions on those? Now, the one thing that I haven't said, I was going to say it earlier, and this is another thing a lot of students mess up on. Do these problems, they try to do this where, like for number 9, they try to say, oh, well, 64 is 2 to the 6, then I make this side 2 to the 6, because that's 64. I like what you're thinking, and I understand exactly where you're coming from. But the whole thing is, or the easiest way to think about it is, we will always want these numbers to get smaller. You can never, I don't want you to add exponents to make this bigger, we can only make them smaller. The reason we can't do that is because you just changed 2 to 64, you can't just do that. I can't just change the number 2 to 64. But I can change 64 to 2 to 6 because those are the same numbers. Really, you took 64 and just change it to 64. But again, the easier way to remember it is just you're always going to make your numbers smaller. If you're making the same base, it's always going to be the smaller of the two numbers. Or even smaller than that for number 10. It might be smaller for both of them, but they're never going to get bigger. All right, go ahead and do those next 3 problems on your own. Same as last time, I'll give you the answers here in a second. The answers I got. That's funny, because when I got 52, I was like, I do not remember getting that last class. I was wrong. Thank you. Not that this is the best way to do it by any means, but just in case you're curious, if you look back at number 8, that is the easiest way to do number 8, but if you wanted to, you could have made 4 into 2 squared, and made 16 into 2 to the 4th, and you could have done it that way with a base of 2. Again, you get the same answer. It would have been more difficult, but I think that's kind of nice to point out after doing number 13, where you use the base of 2 for that one as well. Any questions before we move on? All right, the good news is that's the hardest part of the lesson. We're not done yet. We still have some other things to do, but that's the hardest part. We're not done yet, I guess. Bad news is you're still here with me. So the next thing we're going to look into is we're going to go into logarithms. Logarithms are the inverse of an exponential. Not the put the inverse of exponents. I should have done that. The inverse of an exponent is radical. We talked about that. But the inverse of an exponential, when your exponent is the variable, the inverse of that is a log. And we call logarithms, we call them logs for short. I don't think you guys have ever encountered this at all, so get ready to live. First, the most basics, make sure you know when I say this, this is what I'm talking about. This is how you read this. So this is log base b of y is equal to x. So over there is log base 5 of 25 is equal to 2. You'll hear me say that, and there's not like a verbal part of this test that I'm going to grade you on if you can say it or not. But I always like to start with that just, again, because I don't think you guys have seen this before, and I want to make sure you know what I'm saying when I say it. So very similar to when we did radicals with exponents, you can go from radical form to exponent form, and from exponent form back to radical form. It's the same thing with exponents and with exponentials and logs. So we can start with log form and change it to an exponential, or we can change it from an exponential to a log form. So there's 2 different maps I kind of put up here because I don't know which one is better for you guys. I think it kind of depends on who you are. I like this first one because it's very, it's not super busy. If I'm going from a log form to an exponent form, this is going to be my base of my exponent. This is what it's equal to my exponent. So it's maybe easier to look over here. Your base number goes at the base number for your exponent. The number here goes where it's equal to, and then this answer goes as your exponent. One way I remember this, the base number of your log is the same base number as your exponent, and then your x and y are on opposite sides of the equal sign. So on the left-hand side, it's going to be on the left-hand side over here. My y is on the left-hand side, it's going to be on the right-hand side over here. I like that method because I think that's the hardest part, making sure you know which one goes which for this. So when we get started, we're going from log form to exponential form. So I start with base number 5. 5 raised to the second power is equal to 25. Now, there's 2 really nice things about this problem this way. If I give you a problem like this one, or like number 17, where it's just numbers, there's no variables, your answer should make sense. Other math teachers are like this, or maybe it's just a weird thing about me, but really, it almost makes my skin crawl to give you a problem that doesn't make any sense. I would never give you a problem that would be 5 raised to the 25 is equal to 2. That doesn't make any sense. 5 raised to the 25 is certainly not 2. That's one way to do it. That doesn't help you a lot when we have variables. However, one thing that I think helps is, again, kind of like I said earlier, if this one is equal to 2, this one is certainly not going to be equal to 2. Doesn't make sense. If log base 5 of 25 is 2, why would I change it just to 5 to the 25? So they're not both going to be equal to the same thing. I think, again, that helps me remember which one goes as the exponent, which one goes as the answer. Next one then, raised to x is equal to 27. Again, just think of it as the 27 and the x flip places. Again, they don't really switch places. Equal sign. And the last one, 4 to the 5th, is equal to y. To go with the same theme what we did yesterday, there's no math in this yet. We'll do math with this later. So far, all it is following that math. So again, not to be a broken record, but I really would like to use this as motivation. If you aren't good at math, this is what you have to be good at. The stuff we just got done doing with this, making the same bases and doing the exponents, yeah, if you're not good with that, it's going to be a struggle. I get that. I understand. I totally sympathize and I get it. But this is the stuff, this has nothing to do with math. You can still be good at this if you put forth the work. So go ahead and do numbers 17 through 20 on your own. Then we'll pick back up on 21. All right, so I put my answer out there quick. One thing to remember with this is I'm asking you to put it in exponential form. I'm not asking you to solve anything. So I almost made this mistake, but I've had people do this for number 18 where they write it up here and then they put x is equal to 2. Honestly, if you did that, that's fine. If I can see this, then I will give you credit for that. But if you skip that and just put x is equal to 2, then all of a sudden it's not what I'm looking for. So just make sure you are putting it in exponential form. Any questions on those? Again, I'm hoping that you guys think that's easy. If not, please tell me because it's something I'm not doing correctly. It's not on you. It's certainly on me. 22, just really, this doesn't happen a lot. I guess we'll probably use it more often with our calculators later. But base numbers. If they don't have base numbers, this is called the common log, which you do not have to know. This is called the common log. It's called that because it's that is the most common. Context clues. If they don't have base 10, it's very similar to where if we have a square root, you don't actually put the 2 because we use the square root all the time. We use it way more than any of the other ones. So as math people, they got lazy and said, since it's so common, we don't need to put the 2. Same thing with this one. The log base 10 is so common in math when you get in the higher level of math that they just decide, that wastes a lot of my time. We just won't put 10 there. So, put the 10 there. That's great. However, if I were you, logs and common logs, I would go ahead and put a base 10 in for all those. You don't have to, obviously. Okay, so this one is 10 raised to the x is equal to 100. This is 10 raised to the 5th is equal to x. But especially those problems where you're going to exponential form, I think a lot of people get confused because there's no base number to put in there. So remember, if there's not a base, it's always base 10. Now working the opposite direction, now we have exponential form. We're going to go to log form. And I apparently copied and pasted instead of not, so that should be the other direction. We're starting with exponential form, but I'm sure you are going to be. For this one, again, we're just going to work backwards. So I do the same kind of thing I did earlier, where I know the base number is the same base here, so I know it's log base x. And then I know that these two numbers are on opposite sides of that equal sign. So the 1296 goes first, equal to. Remember, this is not an exponent. Some people put it kind of small up here. I'm not super picky on how, especially if it's hard to tell handwriting. But it's not technically an exponent. Over here we have log base 3. And then again, 243 and x have to be on flip-flop sides. Done that. Nice and handy to think about it that way. Now log base 9 of x is equal to 2. And number 26, I have this starred. And the reason I have this starred is because you don't have to do anything special with this one. You can do whatever, I mean, wrong, so don't do whatever you want, don't just put like 7. But you can put log base 10 of 1,000 is equal to x. That's absolutely fine. To put the 10. So if this is a multiple question, it probably will be just log of 1,000 is equal to x. So it's multiple choice, they might put that, but if you put the 10, make sure you put the 10 in there, that is absolutely fine. Any questions on this yet? Okay, I'm going to erase this to make myself a little bit more room. You do not have to write this down if you want. If you do write this down, there's one mistake, and I am ashamed that I made this mistake. But this should be log base 81 is equal to x. The x and the 4 in the wrong spots. Again, you don't have to write this down. What we're going to do in the next lesson. But I thought it was a good idea to go over right now because the next lesson is literally taking this whole lesson. So the next lesson, we actually solve find out what that x is. We do that is to combine everything from this lesson. So what I mean by that is the first thing is put in exponential form. So 4 raised to the x is equal to 81. Now, just like we did at the beginning of class, 4 raised to what number is 81? So you go 4 raised to, you see I messed it up again still. So 4 raised to what number would be 81, and we'll be able to do this common base. I messed this up, so you can't, but that's the concept. And again, I'm okay with me messing it up in this one because that's what I just want to show you where we're going after this. So really, again, you kind of already know how to do it, is the goal.